Now, here's the thing with the law of cosines. You need to either have, it's got three variables, three sides and an angle. How many sides do I have? Two. And how many angles do I have?
Wait, you actually have three.
I don't even have an angle.
Oh, you don't?
I have a bearing and I have a bearing. But do I know what this angle is? Do I know what this angle is? No, because I'm kind of in trouble. And I'm going to actually help you guys with this part. If you look back, if you think back to geometry, we're headed on some certain bearings. And our bearings are they're oriented due north, right? Due north, due north. Here's our bearings. Back to geometry. These are parallel lines. You guys remember when we have two parallel lines and we have a line that intersects it? We have what's called a transversal. This has been a while. I'm not going to test you on this, but we have to think about it now to be able to figure out this angle. If this is 75, this angle is also 75 because it's what's called an alternate interior angle. Okay? So this is super helpful because if this is 105 and this is 32, you can figure out that angle. Use your calculator, figure out that angle. (105 plus 32), what is it?
137.
137. So I'm just going to kind of erase it. I'm going to put in 137 right here. I used all that information to figure out that that's 137. Now, the good news about this, I have two sides and one angle. Is that enough information now? Yeah, we're good. This is going to be C. And, yeah.
How'd you go on 37?
I got 137. It was 105 plus 32.
Oh.
I'll go ahead and write this in. All right, so we're going to write c squared. That's what we're solving for. We want to solve for this distance. Actually, I'm going to write it farther over. C squared equals, and cosine of c is our angle, 137. What's my a and b going to be? 140 and? You got it. Go ahead and put those in. 675. Now, some of you guys are already reaching for your calculators. You literally need to type this straight in because the variable is already on the side. Type this whole thing in at once, find your sum, and then find that result. So this is literally just typing this in. So 783.2, and that's going to be in terms of miles. That's your C. So now you know that the direct distance between these points, 783.2. Good news here is you have three sides now and an angle. I want you to complete the triangle. Do we need to use law of cosines anymore? What can you use? Law of sines. It's easier. Go ahead and use law of sines. Finish the triangle. Math with you guys because it's been a while, I think, since you guys have cross multiplied. Then you take the sine inverse of this whole thing. 140. You end up taking the sine inverse of all of this, which some of you might have done along the way. And then angle A is equal to 7 degrees. Now, that should make sense with your drawing because this looks like a little itty-bitty angle. Question, Michael?
Isn't sine A? So sine A is the angle, right? And then
Even if you're not done.
Wait, did you guys do like rounding?
Yeah, it was like 6.99 or 7.00. So this is 36. Now, here's where this becomes really important for what you're doing in your project. You're going to have to prove one or two of your vectors using law of cosines. We're going to learn an easier way to do this using vectors. You're going to appreciate it a lot. If this is 75 degrees to here, right? And then this is 7 degrees, what's this new bearing? This is a 75 degree bearing. And if this distance is 7, what's the new bearing? 68. How'd you get 68? All right, perfect. Yeah, because you're moving back. So we used all that information to figure out two things. Your new flight path, if you wanted to go directly, would be a 68 degree bearing, and you would travel 783.2 miles. Okay? Instead of having to go this way and then turn. Now, and what we have here is this 675 miles per hour. This is how fast the plane is moving. But the plane doesn't change direction this time. Instead, we have another force acting upon it. We have wind. And the wind force is moving at this angle, 140 miles per hour. So the question becomes, this final path, is the wind going to influence the plane? Yes. It's going to influence both the speed of the plane and also the direction, right? Because it's a pretty strong wind, pretty large magnitude, right? A couple other things we got to think about. We know that this bearing right here is 75 degrees from the original problem. And then we know that this bearing is 32 degrees. We're going to have to use that information when we look at our vectors. Now, here's how we approach this. We have two vectors, right? We're going to treat each one separately. We're going to look at the plane vector first. It's really going to help to draw a picture. So what you might not notice is this vector is, in fact, a triangle. And we can make it a right triangle. The right angle. 675 is miles per hour. Now the question becomes, we need to find we have its magnitude, right? 675. We need to find its angle. This actually goes back to what Megan was talking about. Talk to your team. If this is 75, maybe I'll help you see this.
Would that be 90?
This whole thing is 90. What's this little sliver that's left?
15.
15. How'd you get 15?
Subtract that from 90.
Subtract from 90. So the vector we're looking at right now is this triangle. You can kind of see it. So we're just looking down here, 15 degrees. You have your magnitude and you have your angle. Can we put this in component form? Put it in component form. Find your x, find your y. What is it? 652?
651.
650, let's say 652. 652, and then what's my second component?
It's 174.
Perfect, write down your components. 652, comma 174.7. What you are doing is you're finding the x and y, or the a and b for this bottom triangle. We're in component form. All right, we've done the plane, right? What's the other force acting upon the plane? The wind. Let's go ahead and some of you probably are seeing where we're going. All right, so round to the nearest tenth, but in this case we're good. So let's do the wind.
Oh, are we going to find the component form for the wind and then combine them?
You got it. All right, so here's our wind. Go ahead, draw on your right triangle. A little different vector. You can see it's a little bit more vertical. Find your theta. So my angle here, it's 90 minus 32 is 58, and my magnitude is 140. Find the components of the wind. 74.2. And my y? I think it's 118.7. Now it's your wind form. Now Alex is on the right track. We have the component form for my plane. We have the component form for my wind. Remember when we were combining vectors? Because that's what we're doing. We're combining forces, right? We drew it this way, head to tail. What we're doing here is we're actually adding the vectors, right? Add the x components, add the y components, find your resultant vector. We call this vector number 3. It's 726.2.
26.2.
726.2.
And 293.4.
293.4.
Four.
Go ahead, box it. All right. Anybody get an answer for C? 783 point. Does that number look familiar? Is that what we got originally? In the last problem, look. What's your distance? 783.2. Now, find your angle. Find your theta. What's theta? 22 degrees. Okay, 22 degrees. Now we got an issue with this. Standard position, right? 22 from here. Figure out the bearing. From due north. This is back to what Megan talked about early on. If this is 22, going this way, what's left? 68. Is this what you got for your bearing in the last problem? It's 22 from taking the tan inverse of these.